Hello everyone, welcome back to the another session in Design and Analysis of Algorithms, Unit 1, Topic 8, Dictionaries. Previous to this video, we were started basic data structures, and dictionary is also one of the data structure. So basically, what is data structure? Organizing the data in a proper manner. If it is linear data structure, arranging of data will be in sequential manner. If it is non-linear data structure, arranging the data will be in not sequential manner. This is what we come across with the topic of basic data structures. What is dictionary? Dictionary is an abstract data type which supports the operations insert, delete and search. In dictionary, the data will get accessed by any of the user having in the form key and value. This is what the form of the data in dictionary. Correct? Now, we'll see some example where dictionary is really applicable. Consider the database of books maintained in a library system. Students who wanted to visit library, either they will take a book from the library or they will return a book to the library. In other terms, what we were saying is getting book from library is what? Deleting the book from the library, and returning a book to the library is what? Inserting a new element to the dictionary. And there is also one more operation which is searching operation. If you wanted to search for a book, you will be going to the index, that is what the value where it is, and with the key. Key is my textbook title or author or the textbook index something. Value is what? Where it is located. So that is what key and value in the dictionary. Now, the best example for this dictionary is binary search trees. A binary search tree is a binary tree. The name itself it tells binary tree is what? It will be having two, at most two, not it will have two. Underline this point. Binary tree is a tree which will have two, at most two children. At most two children. That means it can have 0, it can have 1, it can have 2. That is the reason we wrote this line, it may be empty. That means 0. If it is not empty, that means it have 1 and 2 nodes or childrens. When it is non-empty, that is what? It is having 1 or 2. Now let's see some example. 2 is a node. Okay. Now 2 doesn't have any kind of children. Means it have only one node. If 2 is having the other node, then it is having one children. If it have this figure, it have two children. That is what? Non-empty. Empty in the sense 0, non-empty in the sense it can be 1 or 2. Okay. Now the point comes into the mind, if it have 1 or 2, how the property or how the constraint will be maintained. Let's go with this properties. Every element has a key and no two elements have the same key. The keys in the left of tree smaller than the key in the root. That's what. Look at this. I have given here 2. So this left node should be less than of 2, which is 1. 2 right side should be greater than of 2. That is what the property of binary tree. Binary tree property is what? Left subtree should be always lesser than the key, the root node. The right side should be larger than the root node. It is not for node I am talking, it is for this tree, left subtree, right subtree. Now, what operations will perform in binary search tree? That are searching, inserting, deleting. Okay, and we'll see some example. Before we see an example, let's understand the algorithm of binary tree. Algorithm search, binary search tree. The name is binary search tree. Now, t comma x we wrote. Okay. Now, these are what? Two parameters. If t is equal to 0, then return 0. What is this t? Our target element, what you wanted to search. X is what? The array of elements. Okay. Now, t is equal to 0, then return 0. If my target element is 0, that is return 0. Else if x equal to t to data, then return t. That means if my target element matches with the x, then we will be writing that element. If it is less than, then we will be going for left child. If it is greater than, we will be going for right child. And this is what your recursion operation. This will be recursively happen until you found the element. Now we'll see implementation, how it will take place. Take the example. Example is what? These are the nodes, or these are our keys. These keys has to be get placed into the tree. Now, what is the first element? 11. So I am placing the 11 element into root position. This is my root. So in the properties we were discussed, the node which you are going to insert into the binary search tree, it should get compare with root node. Now 6 will get compare with 11. Now you found 6 is lesser from 11, so 6 place should be left side of 11. Now a third element, you fix the place for 6. Now the third element is what? 8. 8 is what? Lesser than the 11. Correct? Lesser than the 11. So it should come to the left subtree portion. Now in the left subtree, there is one more element which is 6. Now compare your 6 with 8. Sorry, 8 with 6. Now 8 is lesser from 6 or greater from 6 or equal to of 6. If it is greater, it should go to right hand side or right subtree. Then again, once after you find the correct place of your node or your key, again come back to the next element to find the place. Now this time 19. 19 is compare with 11. You found 19 is greater than from 11. Where should it go? It should go to right hand side. That is what 19 will be here. Now again next element. Next element you found, you will be comparing 4 with 11. And you found it is lesser than 11. So come to left subtree. In the left subtree, root node is 6. Again compare with 6. You found it is smaller than 6. So it will be in the left hand side. And you can arrange all these elements in this tree. So finally your tree will be this. This is what actually binary search tree. We will be implementing dictionaries in binary search tree. Thank you all.